How's it going, everyone? Welcome, Eulier Gonzalez. That's right. So, uh, in today's video, I want to finally make a quick recap of how do we get here, especially by exploring is this model pattern or this last chapter of a very interesting and revealing book known as Scope and Closures in JavaScript, written by Kyle Simpson, where the idea is not only to be able to describe the inner mechanisms of JavaScript in terms of what a program is, how JavaScript see a program, how is what is a program at the end of the day, what can we do in our programs, what values are, what values represent in our programs, what values are at the end of the day, which represent is the state of the programs, and what states can we have in our programs, whether it's strings or numbers, and each one of them follows specifically standards or spec. In the case of a string, Unicode, and before that it was the UT6, the ASCII character set, which is a map, or AKA a table that describe or that map or link is one code, a sequence of zeros and ones to a symbol, right? And now, because as the web evolved and not only as the web, because this is something that was developed by the software computing, the software industry, right? So one of them is IBM. So as their products becomes more and more widely available across the world, they need to find a way to actually fill the gap there. So by extending is the character sets and providing now is a more inclusive character sets that go from 0 to 65, 535 different symbols that represent is all the possible known symbols in humans, not only Western characters, but also is Africans, in the Middle East, hand-based characters, or AKA the Asian characters, so Chinese, Korean, Japanese, Mongolian, right? All of this is known as the basic plane. In this Unicode, or this universal, or this UTF-16, right? The universal transform format. So anything that goes beyond that range is known as the astral plane. So for example, we have now emojis, a combination of emojis, right? So for example, is a blonde woman. So for example, basic like a cell phone, or a blonde woman, or a blonde man, or a brown male or woman, or now the family icon, right? So I just mentioned briefly is this because this is part of the technical aspect of what a JavaScript is and a program. So, and especially our values. So this is what the strings allow us, numbers, and also it is trade-off. So for example, that we cannot is accurately represent is specific numbers. So for example, 0.1 and plus 0.2, and that's why we have now 0.333, because there is no accurate way to represent that number. A good example of this is how do we now, for example, is trying to represent in decimal is 1 divided by 3. All right, how you can try to accurately have, so for example, this is easy. For example, if you say I have a pizza and I want to slide that in half, right? So 1 divided by 2 is 0.5. So we have now a finite accurate number. But what happens when you have is long numbers, right? Or particularly numbers whose mathematical operations are not that accurate, right? So for example is 1 divided by 3, right? So you have now all of this computation that you need to do, and if you want to now keep that in memory, well, it turns out that we need to somehow chop off, right? So our memory is not infinite. We would like to. When we do that, we then lose precision. We then lose accuracy. All right. So, but in any case, this is part of the trade-off of using one tool over the another, and in this case, the numbers, and it is a spec, which is the IEEE 754. This is the name of the spec, similar as the ECMAScript 262, which is the spec, and it is the code name for the JavaScript spec. All right. So also we look at other type of values. So for example, is big in the kind of emptiness as well, such as null and undefined. Also is a symbol as well as a boolean. And understand now objects and what objects are and what objects can allow us to represent here. Okay, so this particularly object that it is like a 2-table spreadsheet, right? Or a hash key map value, right? Or n other type of objects. So for example, like sequence of objects, right? Arrays or functions. And when I realized about the functions and how functions are part of the language as a value, to me that was quite mind-bending. Why is this? Because now this functions, aka set of instructions that allows to now be held inside of a variable, and whether it is you define this as a function definition or as a function expression, the difference is that function definition is that you use now a keyword called function to describe what this function is and what it looks like. And if you want to invoke that function, you're going to now is call that function. And function expressions are now functions that we assign is to variables. And when you do that, now you can carry over this functionality in any part of your program, right? But this functionality that you can carry over, it is limited by its scope. So not all players in your program can have access to, and because of that, we explore also is how can we make that in terms of availability, aka how can I make this function is, well, be accessible to everybody in the program, aka the global scope, or in a particular scope. That's why we take a look at the scope here, right? And understand is this nuance between the variables, the functions, and how these variables, or aka these syntax forms, whether it is a var, let, and cons, now they behave in different scope, right? AKA the block scope, the function scope, the catch scope as well, and also is the global scope, right? And just to briefly describe is this technical aspect of the JavaScript, which is uh, well, um after we look at what a function is, how can we define a functions? Also is the the different operations that we can play with our JavaScript values, right? So for example, is that how can we compare its values? How can we convert one value to another? And what are the abstract operations that allow us to happen? AKA, what are the operations that makes that happen? Whether it is intentionally by actually using a particular syntax to transform one value to another, all right, or implicit, that the language does that without our consent, all right. So for example, with if or while, right, or any time that you have this kind of Boolean evaluations. So and also is to understand is what equality is, what part of the the, the comparison of these two objects, okay, what a referential equality means, that might go beyond a little, like that actually is something that might go beyond the scope of today's video, but it's a very revealing uh, concepts in terms of what we can do in our programs and how what a comparison means from the mathematical perspective. So 42 are indeed the same as 42, the same as these characters are indeed as it is, right? The same as this value is indeed the same as undefined, all right? But when it comes to compare now objects, a lot of people say that is because they are now part of the um, different slot in memories. And I want to go a little bit deeper about that, because how do you now is make sure that 42 are actually equal to 42, all right? So this is when this equality identity, because that's what it is, that's what it mentioned is equality identity, okay. Mm, um, if we explore that, exactly, but identity equality. I mean, exactly, it's identity equality. Is identity equality. identity equality. Yeah, but this comparison. Since 42 is the only instance of that value. Yeah, but this comparison is in primitive, for example, 42. Since 42 is the only instance of that value, we are comparing values in the case of primitive by its uniqueness, or aka identity. Exactly. It is. You are drawing is in terms of you are drawing is in terms of the mechanism, right? Are these are these the same 42? Yes, because there is only 42. You know, there is no 42.1, and if it is 42.1, it is 42.1. So it's pretty much like these terms of identity that we talk about in the mathematics, that I know that this is go beyond the scope of today's video, but it's a very thoughtful question to ask yourself, even for your life, right? To say, what is an identity? What is you? All right. If there is any other you out there, all right. Quite frankly, at least in this reality, no. In other reality, it might. If we include now, for example, the quantum mechanics and that kind of physics, all right. but at least in this reality is you, right? This is why I'm hit the brake here to understand now is that this value equality or this identity equality, that's what it means for, right? So when you do this, for example, behind the scenes, what you're doing is just creating is a new array in comparing with a different array, right? This is, of course, is going to throw you false, right? And in the case of primitive, except for symbols, right? And you create now a new symbol and say, hey, symbol, right? Except for symbols, right? They behave now like an object, all right? But for other primitive, that's true. So in any case, this is actually going into the matter of this, the conceptual aspect of the truth of what identity equality actually means at the end of the day. So now we look at that, and also how can we organize our code here in JavaScript, whether it's using functions or classes or ES modules, as well as the low-level features. That is, how can we now iterate through a sequence of elements? What is the iterator protocol? What is the iterable collections or values, right? Whether it's a string or a map or a set or array, okay? And also there are other type of values that follow is this iterable data type, okay? And we have this is because, well, it is quite recurrent that any time that we now have to go to apply some transformations or to iterate through a huge long list of elements, all right, to show that as a user, all right, to show this long list of elements, or to is collect data from the user via forms. Well, a lot of the time it is something that we have to do over and over and over. So this particular pattern, this iterator pattern, which is not new for the language, right? It is a pattern from the design patterns. They say, hey, this is a recurring. This is a common solutions for recurring problems. So is this right? Another is understanding is the features of or the anatomy of the function, all right? Such as closure, what a closure is, as well as the scope, the closure, and the value of this, and what actually this means, okay? And also is the objects, as well as the property that it has, the anatomy of the property. So for example is the object prototype change, aka is a way of how now objects delegate property access to others, all right? Why is that? As a way to now is delegating is the functionality to another object, so you don't have to reinvent the wheel there. So in other words, you just reuse some previous work, which is a lot of the time that's exactly what we're gonna do in our daily jobs. We're not going to reinvent the wheel. Most of the time what we're gonna do is just work on the shoulder of giants, all right? And now push things a little bit further in that domain, in that area, right? So I mention all of this because there are also other low-level features that are quite relevant. So, for example, is the proxy, okay? But this is more like an inherent this is more like built-in objects here that you can go with, all right? And the other inner features, it is now the generators as well as the generator and the asynchronicity in JavaScript, right? This might go beyond the scope of today's video, but all of these things that I mentioned is just a technical aspect of JavaScript, all right? And then we also have now the things that are around the tech, which is who makes the language, the creator of the language, who now owns the legal trademark, who now oversees the spec in JavaScript, right? And so, for example, which is the TC39 group. What is the role of this group? How now this group actually submit and pass a proposal to their internal discussions, aka their several stage from 0 to 4, until that is accepted as a part of the spec. And also that not all browsers are actually going to implement that straightforward. They have their own time to do so. Safari is a very good example of not implementing a lot of these features. Is delegated, is slowing down the implementation of all of this. That's up to them, all right? And despite that, we can now have JavaScript run in different environments. So the browser, the server, the light bulbs, and soon robots, right? Like Unit 3. I really love that robot, bro. It has like, it has, you know, yeah, it's catchy. It's catchy, that robot. Anyways, so it's stylish, you know. It's what was the word? It is aesthetic. You know, it is a mix of aesthetic, thick, and all that kind of jargon, you know. Now, the thing here is that as I mentioned, all of these features, all right, and also is the non-technical aspect of this, and describing is that despite the JavaScript can be run in all of these different environments, the only reality that matters is the web. And those who don't follow for legacy purpose or do backward compatibility, there is a particular appendix in the spec, in the appendix section B, that describe is that behaviors. So because now JavaScript in its conceptions allows to write programs to describe is how the thing is gonna work by the machines in procedural or in functional. So when you only care is about is computing stuff, all right? So you have now is a particularly paradigm that allows to, as a human, easily describe those computations and make it easy for us to maintain those applications, right? And the other is when you need cooperation across different programs, and that is this object-oriented programming, when you need cooperation and coordination, right? I do think that these two distinctions here, if you're able to understand that, or I don't care if you're able to understand it or not, but in my case, and that might sound rough, but the thing is what it is if you truly want to understand what you're doing, whatever craft you are, all of these roads leads to not intellectual effort, not to the philosophical or sound like or a cocktail party conversation that you might have. No, 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 no. All of this is based on true. What is the true of this theme? What is the true of the functional programming? What is the true of the object-oriented programming? And I can quote you certain reference. So, for example, is how do you call it? Grady Butch, which has a very powerful, it have a very revealing podcast with the pragmatic engineer, a software engineer that I think he's working at Uber, something like that. But it turns out that in that podcast, actually, he described is the history of software engineer, all right, and how now people that work on procedural programming, they actually I don't have the actual experience that to actually look and read the procedural code, um, but I can, based on his experience, is that people that are now writing is all of these procedures, uh, they are now finding ways to make now the data and its functionality close together, right? Because this is something that make it easy to maintain and to read and to enhance. Okay, so as I mentioned that, in that at the end of the day, um, that's also something that object-oriented programming and with Grady Butch actually invented, right? Uh, Actually, is now the ability that we have in our programs to now encapsulate code, okay, whether it's with this data and its functionality, and hide some informations to the outside world, and we don't want to expose, right? So, in any case, the different type of paradigms here in JavaScript is that is hey, we can write our programs by only where the only thing that we care is computations, functional programming, or when cooperation and collaboration among other different programs are required as an object-oriented programming. Now, um, in order to understand now how JavaScript work, all right, is by exploring is the inner mechanism and see how the JavaScript engine behave, uh, not as an interpreted language or as an scripted language like we are used to, but it behaves pretty much like a compiled language. The way how it analyzes code, not how the code is distributed. All right. So, for example, when you do now some syntax errors or handy, for example, something like this, and say, "Hey, con salud," right? You say this is hello, right? Then here you say, "Hey, con greeting," okay, and then you say now this will be a function that say print, and it's gonna now console log this, right? And this is gonna do is salute, right? And then you might here say something like this: I want to console log for salute. So if this behaves now like an asynchronous language, you will expect to see hello first, and then now throw some sort of errors. But here it say this. syntax error, missing initializer in counts declarations. In line 3, right? So it's saying, hey, I detect now an error in this line because this is not, there is something wrong here. There is something wrong here. We can also do something like this. Try to reload this. Right? It's like, hey, missing initializer in counts declaration. Hey, this is not a valid initializer. This greeting followed by a dot is not a valid initializer. So we can say something like this, and now it will work. Okay. So, but the point of this is, by recognizing is these three errors, these three behaviors of JavaScript, whether it is how it actually analyze errors, syntax errors, how it's now detecting some early errors, okay, and also is how now scopes in hosting works. This actually describe is and show that JavaScript now have this compile phase rather than be in a scripting, rather than be in a strict scripted language. So as we explore that and how that actually works, all right, and what happened when your file in your ID leave the editor, that is going to pass through a bundler usually, and then that's going to be transformed into a so the bundler is going to pass through a bundler. It's going to pass first to a transpilation phase, right? It might pass through that, and then pass through so the transpilation phase is to transform your code that is evergreen for browsers, and then to the bundling phase that is ready for delivery. And when somebody on the internet now call your website, you're gonna load the JavaScript files. The engine is going to now parse that code, create now is a abstract syntax tree, and then it's going to generate is a the code needed, particularly in the case of the JavaScript, in a depend of the engine as well, into this bit code or this meter representation of the code, this intermediary representation of the code known as bytecode, that is going to further be analyzed for optimizations, and then the code is run. So all of these things is something that is mentioned here in this book. I am not make this up, okay? But it turns out that this description, this is how now based on the observable behaviors in JavaScript. And also we look at some other things, or some other concerns around the JavaScript. So for example, in terms of a speed, so we have now initially back in 2011 something called now ASM.js, where here is now a subset of JavaScript that Mozilla engineers address the concern around how fast JavaScript, or if JavaScript is a fast enough language. So it turns out that they were able to now create and run is or pour is an Unreal game engine into the browser, right? Which set a precedent that JavaScript is indeed a fast enough language to run a game, which is one. And the other is that hey, um, the years after that, years pass, and in 2011, 2013, in 2013, 16, well, it turns out that now the mhm, it turns out that now uh, developers or engineers at Mozilla, now they create is what I'm up in collaboration with others engineers in other industries, right? So they create is now this. So they ask a question: what will happen if we can skip the parsing phase, and now this particular code be ready to be executed in that environment? This is known as WebAssembly. So WebAssembly becomes now is the um, universal compiler target, because now you can use target is a program in a particular language, right? And they now generate the output, whether it's C, Python, Rust, Ruby, and then generate that output in a WebAssembly that is be ready to be executed in this WASP environment. Uh, so again, this might go beyond the scope of today's video. That's actually quite interesting to explore that, and also is what the use strict means here. So, in other words, is because as the JavaScript evolves over the years, and there's some particularly wonky behaviors that happens in the code, and as a way to now enforce developers to write code for have a good chance for optimizing and running that by the engine, that code by the engine. Well, it turns out that now the use strict is here for us. Okay, so rather than go against like a little kids when their parents tell not to do what to do one stuff because it can be dangerous, all right, it is preferably to understand why is that, okay, not only to obey it blindly, but understand why your parents say that, why we are now evaluating is this use strict mode, so we can leverage on the 50 or 60 years of software engineering research, right? In particular is the 30 years of JavaScript research. Now, so after that, okay, we will explore now is the scope. So what the scope is, and so on and so forth, and and that is just to make quick simple, because I do want is to get into what the core of this chapter, the model pattern is. Well, because working with variables and understanding how those variables behave, these syntax forms behave when they are in a particular scope, and also how this scope behave relate to each other. Okay, so when you define a variables in a particular scope, and the way how this scope behave, whether it's a function or a block, so those identifiers from this variable syntax form, whether it's var, let, and cons, are now defined is before the code is executed by the scope. You can call this as the scope manager. Okay, so this is scope. Now it won't alter the identifiers at runtime unless you explicitly do that. All right. So for example, you can have some wild stuff here. Let's say, let's go with the same example here. Let's say function salute. All right, the function salute. And then here you just want is to console log is init value. All right. You can print is init value. All right. And say, hey, init value. All right. Or, and then you can have something outside here and say, hey, it will be now salute, right? Salute. And then say, hey, hola, right? And here, down there, you can have is this. You can say, hey, console.log is now salute. All right. So we know so far that this and this identifiers. So the first belongs to the function, and the second is not to the functions, to the outer scope. All right. And we can now call this. We can say salute, right? So by the time that we call this, it's a hey, you're right. Oh, look at this. This is quite interesting. It's actually working here and say, hey, you cannot redeclare is the same identifier that you use here. So we can call here is greeting, right? And now it'll work. Of course, it show us now it's undefined and hola. But you can now alter is the runtime conditions of this, right? And I do want to explore that just to see that you can do that and that you shouldn't do that, right? So for example, oh, this is defining is inside of the function. So for example is by defining now is an eval here. Again, I know this is something that is quite go beyond the scope, but it's also true that you can say, hey, let define oops and say and say all right, finish that statement, and then you can now here say something like this, oops. Let me actually refresh that. Okay, and it's a, well, actually in this environment it won't work, but if I want to make this to work, on save eval is not allowed source of script. Okay, but in any case, this is because these environments are afraid of what I'm doing and afraid of what users are capable to do. So yes, right. It's evaluating a string as a JavaScript violate the following content security policy. So the browser actually say, hey, no, I don't want to do that. I don't know what you are trying to do. Ain't gonna happen. Let me see if there is another environment that allow me to do this. For example, the copen. Okay. Let me screen out my pen here. There you got it. So for example here, right? And if I inspect the console, somebody done the code, it's a hey reference oops is, what about this? Take it. Because it's this. Now it works, right? Now it works. So you can, again, I know that a lot of people actually, they are not going to do that. This is actually something that you go beyond the scope. That this might look like a nice to have, but the point here is that you now can is modify here is the scope structure here, which is not a good thing, right? You can modify is the scope here. Okay, you can is modify is the scope of that. So not only that, if we go a little bit further in this example, and then we say, hey, let me is define some function inside of this, right? And say, hey, on the greeting, okay, and inside of this greeting, I have is let's say a function called Spanish or English salute, right? And here you want to try have access to the eval by the time that you call that, for example here, and you return now that function, and I know that go beyond the scope of today's video, but the thing here is that you can have access to that runtime scope modification. So what I mentioned here is that understanding is working with variables and scope, and understand that these identifiers that we can now define in a function or in a block, where, so for example, like this, all right? So the decision of the code author where to put the variables, function, and blocks in respect to each other's is analyzed according to the rules of scope. So here in my case, I define is the place where I can put is my variables, functions, and blocks, and also catch, is all determined is by the rules of a scope during the initial parsing compiling phase. The resulting is that is creating is a structure, it's a scope structures that is generally unaffected by runtime conditions, unless you explicitly do that, right? So this actually works, and the matter of all of this is because now in JavaScript, since we have now functions that can be held, these functions are values, and these values can have now is variables inside of that, right? So the scope structure is not going to be altered even after. So the scope structure here is going to maintain the original scope no matter at which part of the program we execute that That's very interesting. So, okay, and I want to clarify a little bit my ideas here. So we are looking at this is because working with variables and functions, is one of the most important thing in any programming language, right? So for exactly in any programming language, right? So the co-author decision on where to put. Mm-hmm. So working. So the TLDR of this is that because understanding that working with variables and scopes are crucial to write programs, uh, and because the decision of the author decision of where to put these variables uh, and functions relate to each other's and the blocks, all of these are now determined by the rules of a scope, which is now calculated, which is determined, which is defined at compile time. Because now functions are values in JavaScript, and this can hold now variables inside of it. This scope structure that is analyzed before the code is executed, it won't be modified by runtime conditions. AKA, this is a closure. And I really love this kind of explanation because it's describing is why do we have this? Okay? Why do we have this? Is the power of a story that actually is the power of a story that actually makes a lot of sense in order to understand the world. Oh, that is very, very interesting. So when somebody, so when somebody tells you what a closure is, okay, if you can describe this in the most effective manner, to convey to the idea is that because working with variables and functions and a scope is the most crucial thing that you need to know in any programming language, right? And since these variables and functions and block scopes, in the case of JavaScript, they are determined. So the way the author decision where to put this are defined by the scope rules, and this won't be altered by runtime modifications because this is now a runtime. This is now this is a runtime. This is a, oh my god. This is this is a scripting language. Okay. So if this is now a compiled language, the story is different. We know that. That and I do think that, and I do think that's a very good question here. In Swift, closure exists. And in order to understand that question, is that again because now scopes based on the what JavaScript is, because now scope is created, or the place where we put now our variables instead of different scope, all of them are defined by these rules, which is determined at parse time, not at compile time. So because it's determined at parse time, it won't be affected by runtime conditions. I'm assuming now that in compile language, you also have closures. You also have closure unless, as long as that language allows you to mhm. As long as that language allows you to as long as that language allows you to have as long as that language allows you to um, have functions as value. My assumption is as long as any programming language have function or make functions as values, you will have them. Mm-hmm. Mm-hmm. And your assumption is spot on. Closures are essentially a direct consequence of treating functions as first-class citizens. If a language lets you pass function as arguments, return function from another function, and store function in variables, then you naturally get closures. Because those functions needs to remember or capture the variable from the surrounding scope. Mm-hmm. Mm-hmm. So yes, first-class functions and closure exactly. It is pretty fundamental relationship in a functional programming. This is a very interesting topic here. When you okay, so we are getting into the weeds. We are getting into the weeds of this. This is also why. This is also why there is another book here known as Functional Light that is written by Kyle Simpson as well. That is exploring is that topic here, functional programming, one whose name variables s, name functions f, and name scope patterns. Engineering manager at Stripe. This is why not. I am not surprised for this. I am definitely not surprised for this. I am definitely not surprised of this. Because when you are now in the banking, when computations are the rules, the transactions that need to be done, well, you actually indeed need is a way to make all of these transactions is easy to understand, easy to read, and follow some of these principles, the ACID principles. Mm-hmm. 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 Engineering manager and Stripe. Hmm. Some people, when faced with a problem, think, I know, I'll use distributed computer. Now they have in power to compute problems. Okay. Okay. And they stop. Okay. Mm-hmm. Mm-hmm. In 2021.
Statement on Form S1 to the U.S. Securities and Exchange Commission, the SEC, relating to its proposed initial public offering of its common stock. The size and price range for the proposed offering have not yet been determined. The initial public offering is expected to commence after the completion of the SEC review process, subject to market and other conditions. This press release is being made pursuant to and in accordance with Rule 135 under the Securities Act of 1933, as amended, the Securities Act, and shall not constitute an offer to sell or the solicitation of an offer to buy any securities. Any offers, solicitations, or offers to buy, or any sales of securities will be made in accordance with the registration requirements of the Securities Act.
Yeah.
Yeah.
Okay, Twin Peaks reboot's gonna be okay. 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 Stripe here. That's interesting, and I do think that was quite intense. Monads are elephant. Okay, monads are elephant party. Monads are elephants. Martians versus monads. So okay, this is some concept from functional programming. Lambda in the sun, shark eye. Java is too academic. Is a Scala for academics and egomaniacs? Oh, here we are. This is back in 2011. Oh my god, you know. And I do get it. Airline is not functional. Okay. Curing and partial obligation. All of these kind of concepts that I know that I'm going to look at that later on. Later on. In 2016, there was past 4 years. Cure flyers, to the ends, type errors as warning, and functional programming here. Why eager language don't have products and lazy language don't have sums? The point of laziness. Prototypes, diggity, some types, diggity, footnotes, and then you got this is actually getting too deep into the rabbit hole, but it all starts with understanding is now the scope here, and what the scope is at the end of the day, right? So if working with variables and functions is one of the most important things that you're gonna do when you are writing and understanding your programs. So the place where you put now your variables, functions, but exactly, it's the place where you put your variables in a function or in a scope. So the place where you put your variables, functions, or blocks with respect each others are analyzing is by these scope rules at compile time. So it generate now in scope structures. It's generating now in scope structures that won't be altered by runtime condition unless you explicitly do that using eval. So because in JavaScript functions are values that you can hold inside of a container, aka a variable, and inside of that functions define variables So the scope structures won't change. So the scope structure will remain no matter where your function is being called. This is closure. Holy moly. Okay. That's a very, very And because closure is something that is part of the functional programming, we can later on take a look at that. Right? We can later on take a look at that. Okay. So functional programming, I know why functional programming has been so powerful in finance, in banking, and also is or in military as well, and also is with the how do you put it? And also is with the object-oriented programming, especially of how you can now make different objects or different part of the programs to cooperate amongst them. Okay, holy moly. Holy F. Okay, but again, I want to summarize this, and I actually want to take some notes out of this, especially in the you don't know or in the JavaScript functional programming. It's not this. But it's more likely this. This is the next step of evolution in the language. This is actually the next step in evolution of the language. Okay. Let me actually take a look at the asynchronous JavaScript. No, it's this one. The you don't know GS. Okay, like this. This is one of the things when you are starting to read content, that the level of deep that require you to understand that topic. This is why a lot of these things make sound cryptic, because the level of deep and truly decide to understand that is in all of this message. The more true are in a content, the more cryptic it sounds, because the level of deep that you must have, and the level of desire to understand must be there. And if it's not, it's not. No problem. No problemo, bro. No problemo. All right. Book 2, Scope and Closures. Here we are. Since working with variables is crucial, since understanding since working with variables and functions, because I will say that it's both for them. Okay. Since working with variables and functions and storing values in them. Working with variables is one of the most fundamental things we do in programming. So since working with variables is one of the most fundamental things we do in programming, okay, since this allows us now is to represent is the state of a programs and store that value there, right? So working with variables, right? So working with variable is one of the most fundamental things we do in programming, and yeah, working with variables is one of the most fundamental things we do in programming. The place we put our variables, functions, and scopes is the place where we put our variables, function, and scope, and it is relation and how it relates. And yeah, you can say that and how it relates. Okay. And how it relates. He's using it with respect to each other. The place where we put our values and scope and how they relate to each other the place where the place we put our variables, functions, and scope and how they relate each others is defined by the rules of a scope, which is determined at compile time, at compile or parsing time. Okay, which are determined at compile, are defined by the rules of a scope, which are determined at compile time. Since functions are values in JavaScript, and we can define variables, so which are determined at compile and parse time and won't be modified by runtime conditions. Okay, unless you explicitly do that. All right. So since functions are values in JavaScript, and we can define variables inside our functions, the scope structure so since functions are value in JavaScript, and we can define variables inside functions, the resulting or the scope structure, the scope structures, the scope structure is Since functions are values and in JavaScript, we can define variables inside functions. The scope structure remains the same. So what do you want to do? The scope structures remains the same. No matter whenever we, the code structures remains no matter at which part of the code we're calling it. So the scope structures remains remains the same. Or how they do this? But they maintains exactly the scope structure. So the scope structures remains the same. So since functions are values in JavaScript, we can define variables inside of functions. It maintains the scope structures no matter whenever no matter at which part of our code we call it. This is closure. Okay. Okay. So this is it, right? This is how you can explain now in this storytelling fashion what a closure is and how a closure are, and then you can get into the detail, which is something that I actually go into and understand that, right? Okay. So what happened here is that we are not reinventing the wheel. We are just only leveraging on we are leveraging so we don't miss is 60 years of software developer in research R&D, and we just only apply all of those concepts but to the web. That's what happened. Holy moly, bro. Shit. All right. Okay. 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 Cool. So in order to now truly understand that, all right? So not only that is closure, and now how closures and models are co-organization pattern characterized by public method that has privileged access via closures to hidden variables and functions in the internal scope of the model. But this is just describing is the entire chapter here. And now getting into the detail here. But again, In today's video, I don't want to get into that. I will leave that as it is, so that'll be all for. Let me actually read about the model pattern. So yeah, in this chapter, we'll wrap up the main text of the books by exploring one of the most important co-organization patterns in all of programming. The model, as we'll see, models are inherently built from what we already covered. The payoff for your efforts in learning lexical scope and closures. Uh, and we have examined every angle of lexical scope, from the breadth of the global scope down through nested block scope, into the intricacies of the variable's life cycle. Then we leverage lexical scope to understand the full power of closures. Like this. Exactly. Then we leverage lexical scope to understand the full power of closure. Wait a single moment. So we have examined every angle of the lexical scope. All right. And how you can actually modify is the runtime scope. You shouldn't, but you see we can do that. And from the breadth of the global scope down through the nested block scope into the intricacy of variables lifecycle. That's what, yes. Then we leverage lexical scope to understand the full power of closure. Take a moment to reflect on how far you have come into this journey so far. We went through is looking first at the looking at the JavaScript, the first book, and then now at the scope and closures by understanding is that why working with variables is one of the most important things that you're gonna do in programming, and because the place where you put now your variables, functions, and block and how they relate each other are defined by the scope rules before the code is executed, aka the scope structures won't be modified by runtime conditions unless you explicitly do that. And because now functions are values in JavaScript, when you can define now these variables, functions, and blocks, it maintains these original scope structures no matter which part of your program you are calling that function. AKA, this is a closure. Okay. And not only to understand that, right? It's also to understand that how JavaScript actually is going into, so how we went through this process of understanding that, all right? So what is a parse language, a compile language? You go into the classical compiler theory, and by looking at that, and how now the compiler classical theory is made of three phases. So you have the parsing, that you have the tokenizer or the lexing, which is going to transform all of these strings of characters into meaningful tokens to the language. Then all of these meaningful tokens is going to now see the relationship of on each one of them, aka creating is the abstract syntax tree, right? During the parsing phase. So now that it knows how all of these tokens are related to each other and the values and the operations and so on and so forth, and the scope structure, right? Now it's going to generate a code. Holy moly. So this is like looking at this particularly pipeline here, and how these machines actually work. This is somewhat similar to mechanicals, motorcycles or car mechanics, right? So when you are now on like um, those mechanical things that you can actually look at what is doing, you can perceive that, right? Here, the way to perceive that is through stories. Mm-hmm. Hmm. 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 Or at least that's what works for me. So in order to understand um, how systems how systems and how do you call this, in order to understand how system works, yeah, to understand how system works, describe it is story, describe it as a story, it what works for me. Mm-hmm. To understand how systems works, describe it as a story works for me. To understand how systems work, describing it or describing them as a story works for me. Mm-hmm. Mm-hmm. Hmm. 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 Mm. Mm. Okay. Mm. Okay. Okay. Hmm. Interesting. Okay. Um. Good. Okay. Yeah. To understand how system work, describing as a story, and that works for me. Absolutely. Absolutely. This requires a systematic approach. Man. This requires a very systematic approach. A very systematic approach. So, so yeah, after we explore is the uh, lexical scope, why this is important, and how now JavaScript, based on its behaviors, when it analyzes the early errors or syntax errors or um, or closure is doing that before the code is executed, right? And we'll look some kind of analogies of how now the lexical scope is. For example, when you have is all of these different buildings, right? And this lexical scope is actually looking at that particularly identifier if that live in one of those buildings, and how it's useful to think that JavaScript now has is a parsing phase and an execution phase where now the scope manager is the central plays the central role of this. First is a conversation that has the compiler when it's going to evaluate it is the identifiers or the variables. Hey, scope manager, the compiler here, do we have these identifiers here? Do we have these identifiers or this or this or this? If it's not, let me add it please the first time. And then on the execution of that code, hey, scope manager, the engine here, let me now is ask you a question. uh, do we have this, right? Because I need to assign or execute a value here, right? So do you have this? So what is the value? Because I need to is assign or execute is a value here in this case, right? Uh, and if that value exists, then I'm gonna apply or execute that. And then we look now at the different type of a scope that we can have, not only functions, but also is the parameters, which is my bending, as well as the block, and how useful for us is to understand the function scope by using is more like function name descriptor rather than arrow functions, because it's lexically available. We can use so we can use the descriptor of the function to be explicit about what this does. Okay. And also is that when you have now other when we look at uh, how this scope behave, how now this identifier is going to be determined via the scope structure. Okay. Also is some other features that we can have that are exclusively in scope. So for example is that shadowing, right? So not only that, but as I explore more about the um, feel of these scopes and other type of scopes that we can have in our JavaScript engines, or in our environments, whether it's a browser, the word service worker, the ES6. This is not a model. This is not an environment, but it's just to illustrate that this particular way of organizing our code is something that we can have access to the global scope, and also is a node, right? So by exploring all of these different environments and it is global scope, and how now variables and functions behave when you do that, the same as let and cons, also we explore is the variables life cycle. All right. So whether it is with var, with functions, and now the hosting, what a hosting is, and also is now how var and functions behave with looping or looping syntax like for in, for off, normal for, while. Also now how let and cons behave in functions and in block scope, as well as in looping syntax. Okay. And when to determine is what to use, whether it's let and cons or var and functions, right? So as I explore that, all right. Um, yeah, absolutely. As I explore that, um, yes. So as I explore that, um, mhm. So as I explore that, all right, uh, and how not this let and cons and variables actually works and so on and so forth. Um, it is also that hmm, Yeah, so I say explore is the variables life cycle, all right, or the hidden cycles or the hidden life cycle in variables in different scope, whether it's function, block, var functions, or let and cons, and also in looping iterations or looping syntax particularly. Looping iteration is quite redundant. Looping syntax also is uh, that how can we now organize our code as a way to avoid some of the common gotchas we can have when we write our applications. So for example, name collisions or exposing unintended dependencies or unexpected behaviors. AKA, how can we now organize our code in a way that is easy for us to write programs and maintain them? Not only write, but read and maintain them. So this is why we look at the principle of least exposure that says that, hey, anytime that you need to use a variable, uh, make that variable accessible to its own scope, because the code will look like much more cleaner. It'll be much more straightforward in how to do so, uh, and you also avoid some of the common problems that I mentioned before, right? And then a question comes here and say, hey, when and how can we use this? When and how can we use this let in cons? And it is up to you to decide when to do that, all right? But at least to understand that not overexposing of identifiers in a particular scope. So try to narrow down those identifiers in that scope, use that, and then now continue to explore that. Also, we look at the hoisting, what a hoisting is, and why we have now hoisting. So, for example, with function is to define the function execution first and the declaration later. And for variables is to define that when we see fit, right? So after that, and then explore now what a closure is, which is now the way of how can we organize our code that. So closure is now how can we now organize our code for variables that we need to use over time in that function, and then we need to execute that function in a different nested scope or in a different scope, right? So this is a way of remembering is this variables reference from the outer scope in the inner scope, and then when we need that function, when we need to have access to that variables, we can execute that function. It also provides now encapsulations and privacy here. So it doesn't allow to expose. It only allows expose is the identifiers that we need and hide data that we don't need to expose to. And I do think this is something that Grady Butch and people like that actually are looking to that. So Grady Butch is one of them. In that interview, right?
No, it was
Where he described is holy hell, that was 11 months ago. Fuck. Jesus. Mm, 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 mm. I do think it's here. I do think it's in this. So I wanna make a quick just recap because all of this was about describing is in this, right? That which is something that we give by this is something that we give by settle, right? In programming, right? Because this has become is the air that we breathe.
That really did not catch full form into the UML long as we overemphasize the notion of inheritance. Inheritance was all about let's save code because we can build generalizations and the like. That proved to not make a lot of sense because we ended up doing lots of disparate kinds of abstractions. That's okay. Fast forward to today, and people say, well, what difference does it make? And the answer is, it's part of the very atmosphere in which you breathe, and so you don't even think about it. You look at, Redis, and you may build things upon it, but if you look at it, you're really dealing with a set of abstractions that Redis offers you, and those abstractions are class-based. So they're baked into the way of thinking of those kinds of systems. So in short, the Booch method was, let's look at the world not through algorithms, but instead through objects and classes. The last thing I'll mention is one of the things the Booch method hinted at that really did not catch full form into the UML was looking at systems through multiple points of view. Now, we'll come back to that in a bit when I talk about Lee Krushton.
Fair use.
So just so I understand, because myself and most of us listening will have started our careers long after the Booch method was invented. For us, classes, variables, inheritance, that's pretty common, pretty everyday things. But as I understand, it wasn't like that back then, right? So could you talk us through what the environment, the technology was like? So that what made the Booch method so new, interesting, or innovative?
Give me a second here.
Well, let me go even further back to the 1950s and show you a parallel story. There was a time in the growth of algorithmic programming languages where the idea of a subroutine was considered controversial. Why? Because doing a function call added at least 2 or 3 more instructions, which was computationally expensive. So even function calls and decomposing something into subroutines was viewed as an architectural aberration, and people opposed it because it was inefficient. Well, obviously, we think, well, that was stupid because we need it for our management of complexity. The same thing, I think, was true back in the days of early.
You know, it's not what you think it is what it is, man. So they need to decompose this is for maintainability, is for managing the complexity here.
Object orientation. I mean, people were doing object orientation in algorithmic languages because you'd have these things in COBOL called, common data areas. People would devise, here's all this common data, and as a matter of practice, but not language, you would say this data is used in this way by these algorithms and vice versa. In fact, going back to that project I mentioned to you at Vandenberg Air Force Base with those 32 computers, on the side of every one of those computers, every day, we'd see a printout of here is the common data pool. And so it was the abstractions right in your face because they changed. And so people were trying to do algorithmic or object-oriented decompositions, but the languages didn't support it. There was a need to do that kind of thing. And until the languages came into play, there was no way to bring those ideas together efficiently. And so, yes, the Booch method was very much a reaction to the forces upon building software-intensive systems to look at classes, trying to apply it with modern languages and building a methodology around it. Today, we take it for granted. The forces upon building software-intensive systems to look at classes, trying to apply it with modern languages and building a methodology around it. Today, we take it for granted because our languages make it easy for us to do this.
It's just fascinating to think back how revolutionary it was and compare to just how commonplace it is. And also to think about how things that we invent today and that are revolutionary in 20 years, people will be like, oh yeah, that's commonplace.
Yeah. Right, exactly.
One thing that you're known for, and you also mentioned you're associated with it, is UML. But
he mentioned is something
I understand
the
it has to do with object-oriented programming. But coming from you as the person who invented it, it would be nice to explain what it is and why it was important.
Well, let's go back to Plato. Talking about going way back. I wasn't around then, but I've read about him a little bit.
I wasn't around that, but I read a lot about it. I wasn't around that, but I read a lot about it.
This wonderful treatise he wrote, The Dialogue, in which there's a debate about how one should best look at the world. Should I look at it as atoms, or should I look at it as processes? Well, the first golden age of software engineering was more focused upon the processes, the algorithms. But there's a parallel way of looking at the world, and that's looking at it through the atoms, if you will, the classes and objects within them. So yes, I was influenced by abstract data type theory, by Plato, by a lot of other interesting philosophical things that were coming together at the time of looking at the world in fundamentally different ways. So the Booch method was really trying to codify that. How could we decompose systems not based upon algorithms, but how do we decompose it based upon classes and objects? And again, that's where I was influenced by Liskov and Parnas and Dijkstra and Hoare and the like. Names that are probably unfamiliar to students these days, but they were representing the theoretical underpinnings of the first and second generation. The Booch method was basically saying, hey, here's a new way of thinking about the world. And so it said, look not at algorithms, but look at combining data and processes, algorithms together in one thing, thereby classes. Now, we did some things right, we did some things wrong. I think the things we did right was Classes make a lot of sense in terms of abstraction. What we did wrong is we overemphasized the notion of inheritance. Inheritance was all about let's save code because we can build generalizations and the like. That proved to not make a lot of sense because we ended up doing lots of disparate kinds of abstractions. That's okay. Fast forward to today, and people say, well, what difference does it make? And the answer is, it's part of the very atmosphere in which you breathe, and so you don't even think about it. You look at,
I just wanted to make a quick pause here because he mentioned something that at the end of the day, which is I want to relate to what I am looking right now. Okay, not the functional light, but here of models and closures and what closures allows in that come from the functional programming, right? Which is these processes of how you can describe is a particularly step by step or an algorithm, okay? And how now we can encapsulate is these models, or how can we now use these closures as a way to now is define variables from the outer scope, right? Hold that reference, and anytime in the different part of the program, you can have access or update that value, right? Without exposing that data, all right? Or without exposing is the reference to that. So as we explore that with closures and how can we look at closures, so from the theoretical so from the observable behavior of closure is that when you now is reference the variables from the outer function scope and you create now an instance of that function, yeah, and then you can create that instance of that functions and later on execute that in a different scope. This is the observable behavior of what a closure is, and that makes a lot of sense. Holy moly. That makes a lot of sense what a closure is and the observable behaviors, right? So you are referring is a variable from the outer scope in a functions. These functions, you create an instance of that, right? And that instance now you can execute in a different part of your programs, so you can still have reference to that variables. So because we are holding reference here, it is important also to figuring out how to remove those reference after that. And the way to do that is that if you create multiple functions reference of that, if you create multiple functions instance, all right, if none of 10s are removed, that last one function's reference still now still hold that reference to that variables. Until that is gone, now it is candidate for the garbage collector to be collected, right? So this is the holy grail, the whole point of using now closures, or to understand now closures in our programs, okay? And what is the valuable stuff that we can go with functions. So a pretty straightforward example is like we can also create now with function is so for example is that anytime that we want to hold the value, so for example a bouncer, I don't have an input, there's an input here like this, all right, so this is now an input. It's not even an explicit input. That's there you got it. There you got it. Exactly. It's not even an explicit input here. Look at you. It's not even an explicit input. It's like a custom input here. QB search input. QB input here. Okay. QB core framework. Lua framework for 5M. Okay. It's Lua. Lua, the language. Holy moly. Okay. Interesting. So alright, Lua is another language. Lua language. I'm not quite familiar with that. The programming language Lua. About news, get started to load that. The programming language here, but the thing is, designed and developed by Puck Rio. Oh, interesting. Lua. What? And about this. Lua is a powerful, efficient, lightweight, embedded scripting language. Okay. So this is somewhat similar to JavaScript, right? It supports several programming styles: procedural, object-oriented, functional, data-driven, I'm not quite familiar, and data description. So Lua combines simple procedural syntax with powerful data descriptions, construct based on associative array and extensible semantics. Lua is dynamically typed, runs by interpreting bytecode, with a register-based virtual machine, and has automatic memory management with incremental garbage collection, make it ideal for configuration, scripting, and rapid prototyping here. Lua has been used in many applications, in many industrial applications. So for example, Adobe's Photoshop Lightroom, with an emphasis on embedded systems, A.A., Jenga, and games, the World of Warcraft and Angry Games. Lua is currently the leading scripting language in games. Lua has a solid reference manual. Okay, in games. Okay, the engine server general results. Interesting. In games. It's interesting that it's an scripted dynamic language. And why not compiler language? What are you using for rapid prototyping? Lua. This query support multiple, making the decision of engine. Okay. But in any case, you get the idea, right? Lua, pronounced Lua, means moons in Portuguese. Lua. It's because this language was created in Brazil. What the hell? Lua is powerful but simple. Lua is small and Lua is free. That's interesting. This is an scripted language. It's a light, powerful, efficient, lightweight, embedded scripted language. So anytime that you look at this scripted language, is dynamic. It's not an static, and so on and so forth. Okay, that's quite interesting. Why am I looking at this? Is based on this. Is based on this. Is based on this. It's based on this particular input. This comes from that particular framework. Okay, that's interesting. So they are not using it as an input as it is. They are using it. Yes. But at the end of the day, they must rely is on that. So for example, if I try to have access to that via this, which is something that I don't recommend you to do that, guys. You shouldn't do that. It say no, I don't have anyone. Oh, I need to add this because it's using a selector. No? That's interesting. Or I can say is this one. No, because this is looking for by ID. Yeah, this is looking is by ID. This is looking is by ID. And if this doesn't have an ID, it means that it cannot be queryable. It means that it cannot be queryable here. So, but in any case, all of this is just to describe is this particular nature of the language, and it is, right? So, so the central thing of this book has been that understanding and mastering scope and closure is key in properly structuring and organizing our code, especially the decision on where to store information in variables. Our goal in this final chapter is to appreciate how modules embody the importance of these topics, elevating them from abstract concepts to concrete, practical improvement in building programs. So encapsulation and least exposures. So encapsulation is often cited as a principle of object-oriented programming, but is more fundamental and broadly applicable than that. The goal of encapsulation is the bundling or co-location of information, data, and behavior functions that together serve as a common purpose, which is exactly what the Grady Bush actually mentioned here. And based on my own experience is that how can I make this data that is describing something and it is methods that is operations on that data together. So independent of any syntax or code mechanism, the spirit of encapsulation can be realized in something as single as using separate files to hold bits or overall programs with common purpose. If we bundle everything that powers a list of search results into a single file called searchlist.js, we are encapsulating that part of the program. Exactly, if we bundle up everything in there. The recent trends in modern front-end programming to organize applications around components architecture push encapsulation even further. For many, it feels natural to consolidate everything that constitutes the search result list. Even beyond code, including presentational markups and styling, including logic into a single unit of program logic. So something tangible that we can interact with. So for example, in the case of React or Angular or Vue, right? And then we label that collection the search list component. This is exactly what we're doing here. So another key goal is the control of visibility of certain aspect of the encapsulated data and functionality. recall from chapter 6 the least exposure principle, which seeks to defensively guard against various dangers. Which seeks to defensively guard against various dangers of scope overexposure. This affects both variables and functions, and in JavaScript, we most often implement visibility control through mechanism of lexical scope. Exactly. Hey, I do want this visibility mechanism is implementing in JavaScript as a scope or lexical scope. The ideal is to group alike programs, bits together, and selectively limit programmatic access to part we consider private details. Exactly. What's not considered private is then marked as public, accessible to the whole programs. The natural effect of this effort is better code organization. It is easy to build and maintain software when we know when things are, with clear and obvious boundary and connection points. It is also easy to maintain quality if we avoid the pitfall of overexposed data and functionality. These are some of the main benefits of organizing JavaScript programs into models. So that is the TLDR of all of this is that since by understanding now how to work with functions, how to work, why working with variables is one of the most important things in programming language, and that is because our programs now needs to hold values in to represent a state of the programs. So understanding is that how variables and functions and blocks are related to each other's, and when we put that, how that affect to each other's. Okay, all of these are defined by the scope rules, which are now not altered by runtime conditions. So this is structures, right? That when we, and because JavaScript now treat functions as values, and those values now can held is variables inside of that, right? The scope structure is remain across any part of the program that function is called, aka a closure. So a closure now act as a way to organize our code to not overexposing details, so we can prevent a series of problems, that is name collisions, unintended dependencies, or unexpected behaviors, right? And by hiding now those details and only exposing that, not only we make our application much more secure, but also easy to maintain and easy to organize, which is something that we see now here in JavaScript, or in the trends of the modern web development, the front-end programming, which is by using is or by combining is the presentational with the markup in a programming logic unit, that we can interact to this and put a label on that, an identifier too. This is how we can now easily encapsulate the models and make it easy to maintain the application as well. Okay, so this private and public details, all right, so the natural effect of this effort is better code organization, right? So there are some main benefits of organizing JavaScript programs into models. And what is a model, you may wonder? So a model is a collection of related data and functions, often refers to as method in this context. Characterized by a division between hidden private details and public accessible details, usually called the public API. A model is also stateful, aka it maintains the state or it maintains that information over time. When you look at stateful or stateless, it's because that unit maintains that protocol, that unit maintains that information over time. So HTTP is an stateless protocol because it doesn't maintain any data over time. Okay. A model is also stateful because it maintains some information over time, along with functionality to access and updating that information. So a broader concept of the model pattern is fully embracing system level modularization through loose coupling and other progress architecture. That's a complex topic that well beyond the bounds of this discussion, but is worth further study beyond this book. To get a better sense of what a model is, let's compare some model characteristics to useful code patterns that aren't quite models. Okay. So now that we know what a model is, all right, which is a collection of related of data and its functionality, okay, characterized by the division of the private and public details. And public means is and public usually called the public API. The modeling in itself is stateful, aka it maintains some informations over time and it is functionality. And it is functionality to access and updating that information. So a broader concern of the model pattern is to fully embrace system level modularizations through loose coupling and other progress architectures techniques. That's a complex topic that will be beyond the bounds of our discussion, but it's worth further study beyond this book. To get a better sense of what a model is, let's compare some characteristics to useful code patterns that are quite models. So for example, namespace. So namespace, they don't hold or maintain any information. They just are a place to put related functionalities. The other is the data structures. So they are a stateful grouping. Yes, here you can now is store some data, and it is functionality, all right. But you can have access to all of the data inside of that. So there is no separation of private and hidden, private and public details here. So there is no visibility control mechanism. And the models which are stateful in access control. To embody the full spirit of the model pattern, we not only need grouping and state, but also access control through visibility, private and public. Let's turn student from the previous sections into a model, and we'll start with a form I call the classic model, which was originally referred to as the revealing model when it first emerged in the early 2000s. Consider this. Exactly. This is how it was revealed initially, because now you are holding in this scope is the data and its functionality, and expose only those details that you need to. And if you somehow need to access or update the data, you expose via this public interface. So how does the classic model format works? Notice that the instance of the model is created by the defined students, exactly here, and immediately invoked function expression being executed. The immediately invoked functions returns an object named public API that has a property on it is referencing the inner get name functions. And naming the object public API is a stylistic preference of my part. The object can be named whatever you like. JavaScript doesn't care. Or you can just return an object directly without assigning to an internal name variable. Moreover, in this choice of appendix X. So here it chooses now public API, but most of the time we just return is this. In this case, we use this because we can now have, referencing this identifier. We can is expose it and define is what we want to expose. We make it obvious to what we're going to expose, which is something that you are not going to find a lot of the time. And whether it is AMD or UMD, which is our way of how you can organize your code, all right, in part of the appendix A. From the outside, students that get names invoke this expose inner function, which maintain access to the inner records, variable via closure. You don't have to return an object with a function as one of its property. You can just return a functions directly in place of the object that still satisfies all the core bits of a classic model. By virtue of how lexical scope works, defining variables and function inside your outer model definition, function make everything by default private. Only properties added to the public objects returned from the function will be exported for external public use. And the use of immediately invoked function expressions that our programs only ever need a single central instance of the model, commonly referred as a singleton. Again, a particularity pattern. Indeed, this specific example is simple enough that there is no obvious reason we need anything more than just one instance of the student model. Model factory, multiple instances. But if we did want to define a model that supports multiple instances in our programs, we can slightly tweak the code. Function factory function, exactly. So if you want to create new instance of this, you just only define is that as a function, right? And anytime that you need to, well, you just create a new instance of that. Rather than specifying the defined student as an immediate function expression, we just define it as a normal standalone function, which is commonly referred to in this context as the model factory. We then call the model factory producing an instance of a model that we label full-time, and this model instance imply a new instance of the inner scope, and thus a new closure that get names, holds over records. Full-time that get the names now invokes the methods on the specific instance. Classic model definitions. So to clarify what makes something a classic model, there must be an outer scope, typically there must be an outer scope. Exactly. To clarify what makes a classic model is, there must be an outer scope, typically from a model factory function running at least once. The model inner scope must have at least one piece of hidden information that represents state of them for the model, and the model must return on its public APIs a reference to at least one of function that has closure over hidden model states, so that this state is actually preserved. You'll likely run across over other variations on this classic model approach, which we will look at the more detail in Appendix A. And then we look now at the node models here. In Chapter 4, we introduce the common JS models, format, used by Node. Unlike the classic model format described earlier, where you call bundle the model factory or as an IIFE alongside any other code, including other models, CommonJS models are file-based. One model per file. Let's tweak our model examples to adhere to that format. So now this is one model per file. So model export.get name, and well, you have now this. So you are defining is here this. The records and get names identifiers are in the top level scope in this model, but here you are now explicitly is exporting is the functionality to that, but that's not the global scope exactly, because we are in the node environment, the CommonJS. To expose something on the public API of a CommonJS model, you add a property to the empty object provided as model.export. In some older legacy codes, you may run across reference to just our bare export. But for code clarity, you should always fully qualify that reference with the model prefix. For style purpose, I like to put my export at the top, but sometimes you're gonna do is that at the bottom. Some developers have the habit of replacing the default export object like this. Right? There are some quirks with this approach, including unexpected behavior in multiple such models. Circular depend on each other. As such, it recommends against replacing the object. If you want to assign multiple export at once, using object literal style definition, you can do this. Because if you do that, and then another model export other. Let's think about this. If you have different files, and each one of those, for example, export different set of models, right? What happens is that if one of them are the same, so which reference are you using? Of course, the one who are importing from that. But also that you can have circular reference. So in order to prevent those circular reference, we use object.assign. That is say, hey, I want to now copy all of the keys, or I want to copy all of the property from the source to these target objects. So from the source to this target object. So what's happening here is defining the object literal with your models public API specify, and then the object.assign is perform a shallow copy of all of the property onto the existing model export. Exactly, it's doing is a shallow copy. I'm going to copy shallowly. When I do a shallow copy, instead of replacing it, this is a nice balance of convenience and safe model behaviors. So to include another model instance into your model programs, use nodes require methods. Assuming this model is located at path to student.js, this is how we can have access to. You put in the name, you have access to, and then you have now a reference to that model. So student now reference the public API of our example model. CommonJS model behave as a singleton instance, similar to immediately invoke function model definition style presents before. No matter how many times you require the same model, you just get additional reference to the single shared model instance. Require is in an all or nothing mechanism. It includes a reference of the entire exposed public API of the model. To effectively access only part of the API, we typically approach looks like this. So we just destructuring it, because at the end of the day, we're receiving is that as an object model export. Similar to the classic model format, the public export method of CommonGX Model API holds closures over the internal model details. That's how model singletons state is maintained across the lifetime of your program. Similar to classic model format, the publicly export method of CommonGX Model API holds closures. Oh, because it's this. Exactly. The policy export method of CommonJS hold closure over internal model details. Exactly. So this method that is exposed by that models is closing over internal details of that model. That's how the model singleton state is maintained across the lifetime of your program. Ignore requires student statement, not absolute path. Student as GS. File extension and search node model here. And then you have now the model ES model here. The ESM format shares several similarities with the CommonJS format. ESM is a file base and model instance are singletons. Exactly. Share several similarities with CommonJS. ESM is a file base and model instance are singletons. Okay? It only exists once. With everything private by default. One notable difference is that ESM files are assumed to be a strict mode. Okay. Okay. One notable difference is that ESM files assumes to be a strict mode without needing a use strict pragma at the top. There is no way to define ESM as a non-strict mode. Instead of model export in CommonJS, ESM use export keyword or import keyword. Export to expose something that is public, and import that replaces require. And let's adjust student.js to the use ESM format, which is export this, and this is the private details, right? You are defining as a functionality that is closing over records here, right? That is closing over record, right? And the only change here is the export get name statement. As before, export statements can appear anywhere throughout the programs, and function export must be at the top level scope. It cannot be inside any other block or function. ESMs offer a fair bit of variation of how the export statement can be specified. So for example, you get this, right? Even though export appears before the function's keyword here, this form is still a function's declaration that also happens to be exported. That is, the gate name is identifier is functions hosted. See chapter 5. Is also for okay. So the get name identifiers is functions hosted. Interesting. See chapter 5. So it is available through the whole scope of the models here. Because we are looking at now the models here. Another allowed variation is this export default function get name student ID. So this is a so-called default export, which means has the different semantics for another export. In essence, a default export is a shorthand for consumer of the model when they import that, giving them a third syntax when they only need the single default API member, which is heavily used on describing is this unit of UI in React, to do so. The import keyword, like export, is must be used only at a top level of an ESM outside of any blocks or functions. Also has a number of variations in syntax. The first is refers to name import, like this, and you can see this form imports only the specifically named public API members from a model, skipping anything not named explicitly, and it adds those identifiers to the top level scope of the current model. This type of import is a familiar style to those used to package import in language like Java. Mhm. Multiple API members can be listed inside of this set, separate with commas. A name import can also be renamed with the as keyword. Excited to add now an alias. If getName is the default export of the model, we can import it like this. The only difference here is dropping the curly braces around the import binding. If you want to mix default imports with other name import, you can do as it is. Default as getName. By contrast, the other major variation of import is called namespace import. As is likely obvious, the everything this asterisk import everything exported to the API, default and name, and store it all under the single namespace identifier as specified. This approach most closely matched the form of classic model for most of the JavaScript history. As of time of this writing, Motor Browser has supported ESM for a few years now, but no established support of ESM is fairly recent and has been evolving for a while. The evolution is likely to continue for another year or more. The introduction of ESM to JavaScript back in ES6 created a number of challenging compatibility concerns for Node.js interoperability with CommonJS model, and consult now the ES documentation for all the latest detail of this. Whether you use a classic model format, browser or Node, or CommonJS format in Node, or ES format for browser or Node, models are one of the most effective way to structure and organize your program's functionality and data. So the model pattern is the conclusion of a journey in this book of learning how can we use the rules of lexical scope to place value. Okay, how can we use the rules of lexical scope to place variables and functions in proper locations? Principle of least exposure is a defensive private by default postures we always take, making sure we avoid overexposure and interact only with the minimal public API surface necessary. And underneath model, the magic of how all model state is maintained is closures leveraging the lexical scope system. That is for the main text. Congratulations on quite a journey so far. I have said a number of times through, it is really good idea to pause, reflect, and practice what you have discussed. When you are comfortable and really and ready, check our appendix, which dig deeper into some of the corner of this topic, and also challenge with you some practice exercise to solidify what you have learned. Holy moly, bro. Mhm. Oh, this is what exercise. Mm. Mm. Mhm. Mm-hmm. Interesting. Okay. Mm-hmm. What is it? Some exercise here. Suggested models. Mm-hmm. Mm-hmm. That'll be all for this video. Take care. Bye bye.